السلام عليكم ورحمة الله وبركاته. مكملين مع بعض مراجعة لجريد 9 أدفانس، ومعانا السؤال رقم 21. According to the graph position time graph of two children, Muhammad and Salim, beginning to move together at the same time from different position. Look to this figure. Salim start from 0 position, but Muhammad start from 6 position 6, as you see, 0 2 4 6. Okay, he asked me what is the distance between Muhammad and Salim at the beginning. Look, Salim start from this point, from 0 point. I can highlight it by this color, by this color. Salim started from this position and Muhammad started from this position. The distance between Muhammad and Salim is 6 meter. 6 minus 0, it will be 6 meter. Okay, what is the distance between Muhammad and Salim at the beginning? Equal 6 meter. Determine both the time and the position where the two children met. They met at this position. Look carefully to this point. They are met at this point. This point at which time? It's easy. The time is, if you look here, they are met at 8 seconds. They are met at this point, 8 seconds. At which position they are met? At which position? We can draw the horizontal line like this. They met at this position, between, in the middle between 12 and 16. It will be what? It will be 14 exactly. So that the time is 8 seconds and the position is 14 seconds. Find the average velocity of Muhammad. Average velocity of Muhammad, we know this is position time graph. In position time graph, the slope equal what? Velocity. Exactly. Slope equal velocity. So that if I need to calculate to get average velocity for Muhammad, I take 2 points in Muhammad lines like this. I take these 2 points. This point, it's clear. This point 10 and 16, and I take another point in Muhammad graphs. I can take this. This is 2 and 8. 2 and 8. Now we can write V, average velocity, equal y2 minus y1 equal x2 minus x1. This is the slope for this graph, for Muhammad's graph. y2 is 16 minus 8 divide 10 minus 2. The answer will be 1 meter per second. We can write it like that. We can write it V equal x final minus x initial divide t final minus t initial, and write the same numbers. The same numbers exactly. The answer will also 1 meter per second. It is the average velocity of Muhammad. Question 22. Hamdan throw, I take the line to make this question separated. Hamdan threw the ball vertically upward with a speed of 20 meters per second. He threw this ball from this point and throw it upward. What will happen to the velocity? Increases or decreases? Exactly. The velocity will decreases, then decreases more and more to reach to zero. At the highest point, the velocity will equal zero. Great. So that 20 meters per second is V initial. V initial is 20 meters per second. What is the speed of the ball? What is the speed of the ball? We need final velocity when it is at maximum height. I said at maximum height velocity equals zero. To start with 20 meters per second, the velocity decreases more and more and more and reach to 0 meters per second at the highest point. Number B, what is the acceleration? Acceleration of the ball equal gravitational acceleration equal negative 9.81 meter per second square. Why it's equal negative? Because the acceleration to down, acceleration to refer to down. Okay, gravitational acceleration to down. The next question, a period of time 4 times 10 to the negative 3 seconds. Which of the following is true for this period with prefixes? 10 to the negative 3 is what? Is millisecond. It means 4 milliseconds. Okay, prefixes, as I told you before, we have a lot of prefixes. Centimeter equal 10 to the negative 2 meter. Millimeter 10 to the negative 3 meter. Micrometer 10 to the negative 6 meter. Nanometer 10 to the negative 9 meter, and so on. And there is a kilometer equal what? It's not kilometer. Kilometer equal 10 to the power 3 meter. Mega, kilo, mega, giga. Kilo, mega, giga. Megahertz equal 10 to the power 6 hertz. Gigabyte equal 10 power 9 byte. Okay, another question. A period of time is 2 times 10 to the negative 3. Exactly the same. 10 to the negative 3 is millisecond. 2 milliseconds is the correct answer. The next one, depending on the figure, what is the measurement of the road length including the uncertainty number? Okay, if we make a zoom for this reading, we get around, I use this color, this is our reading at this point. All of us know it's 11.5. Is it correct? Exactly. 11.5 centimeter. Great. But I think it's more than 0.5. It may be 0.52, 0.53, 0.54. It is uncertainty number. There is uncertainty number. How can I calculate the uncertainty number? Okay. Make it smaller again. This ruler We can measure it. The smallest number we can measure it is what? Is 1 millimeter. The smallest digit in this ruler is 1 milli, 2 milli, 4, 5, 3 milli, 5 milli, like that, to reach 1 centi, then 1 centi, 0.1, and so on. So that the smallest reading we can read it is 1 millimeter. The smallest digit is what? 1 millimeter in this ruler. So that the uncertainty, we can measure it by 1 millimeter divided 2. It will be 0.5 millimeter. But the reading, we write it in centimeter. Can we convert from centimeter to meter? Yes, we can. It's easy. 11.5 centimeter. We need to convert it to millimeter. As you see, 1 centimeter equal how many millimeter? It's equal 10 millimeter. Is it correct? 1 centimeter equal 10 millimeter. So that 11.5 centimeter equal how many millimeter? It will equal 11.5 times 10 millimeter. It will be 115. Is it correct? Millimeter. But as I told you, this is not exactly 11.5. It's greater than 11.5. It means maybe we can write it like that: 115.5 millimeter. It's exactly more than this number or smaller than this number by this amount. It's called uncertainty number. So that the correct answer will be 115.5 plus or minus 0.5. There is no reading. We can make it like that. There is a wrong answer. We can make it like 0.5. Number C and D is the same, so I will change one, and this will be the correct answer. Okay. This mistake can happen normally in exams. Okay, this is 0.5. It's clear, yes? Again, the reading is 11.5 or greater than 11.5. I convert 11.5 centimeter to millimeter. I get 115 millimeter, but it's more than 115, so that it will be 115.5 millimeter. What about uncertainty number? The smallest digit is 1 millimeter. I divide it by 2. I get 0.5 millimeter. So that the reading will be 115.5 plus or minus 0.5 millimeter. Another question. Ahmed starts for his school in the morning. There is a straight road that connects his house to the school. The value of his position distance from the house are listed in each time interval in the table below. Time 0, 30, 60, like that. And this is the position. We need to draw the position time graph to represent Ahmed motion from home to school. We can make it like that: time 0, 30, 60, 90, 120, 150, 180, 210. This is the time in second. What about position? Position 50, 100, 150, 200, 250, 300, 350. This is the position in meter. And we can put the dotted like this and so on. We can take a straight line for the Ahmed's motion. I draw the graph represent Ahmed's motion. Calculate the average velocity. It's easy. Average velocity equals the slope for this graph. Slope equal V average. It means y2 minus y1 divide x2 minus x1. I can take any 2 points like this, 90 and 150, and this point 0 0. The answer will be the average equal 150 minus 0 divide 90 minus 0. The answer will be 150 divide 90, 1.67 meter per second. Calculate the average velocity of Ahmed's on return trip home if he reached back home in 5 minutes. The total distance taken from 0 to 35, the total distance is 350. Distance equal 350 meters. Okay. When he returns back, this distance will be negative because it's in positive direction. So that displacement when he returns back is delta x will be negative 350. The time taken in this trip is 5 minutes. 5 minutes times 60, it will be 300 seconds. So that the average velocity when he returns back, V equal delta x over time, it will be negative 350 divide 300. The answer will be negative 1.17 meter per second. The next question, I think the same, but the difference in number. We take this question. Depending on the equation, y equals 6 meter per second plus 3 meter per second squared times x. What is the name of the physical quantity x and the unit for x? Okay, y is position. Yes, it's correct. Y measured in what? The position, we measured it in meter. We measure this in meter. Great. No, I write it down. Sorry. Y equal 6 meter per second plus 3 meter per second square times what? Times x. He asked about x, the unit, and what it represents. I'm sorry. This parameter measured in what? Measured in meter per second. So that we must add this parameter, also it must be meter per second. Is it correct? Meter per second plus meter per second. I can't add meter per second to kilogram. I can't add meter per second to joule. It must meter per second. But the second parameter is two things, 3 and x. So that this meter per second, it must be two things multiplied to each other. It is meter per second square multiplied by something. I need to multiply this by something to get meter per second. Exactly. We must multiply it by second. Why? Because if I multiply it by second, the second will cancel with the square and I get the answer meter per second. So that x is second. Which physics quantity measured in second? The time. So that our answer will be time and the unit will be second. Our answer is number C. Okay, this is our answer. Time, x is time and measured in second. The same question, but with different strategy. We write again y equal 3 meter per second plus x multiply by 2 seconds. The first part of the equation meter per second, so that the next part must be meter per second. This is two things. Something I don't know the unit for it, it's called x, and the other thing the unit is second. I need to get meter per second. What should I write here? I will write meter. I need to get meter per second, so that I write meter divide second square. Is it correct? Yes, it's correct. Why? Because if I delete second with this square, I will get meter per second again. Okay, meter per second square. This unit for what? Exactly, this unit for acceleration. This unit for acceleration. Yeah, our answer will be acceleration, and the unit is meter times the second to the negative 2, or meter per second square. They are the same, meter per second square. The next question, depending on the figure, what is the displacement for the car after 0.3 seconds from the beginning of its movement? If you look to this figure, the time period 0.15 between the two each images. Yani the time from this image to this image, 0.15. And the time from this image to this image, another 0.15. Is it correct? So that this time 0.15, the 0.15, if I add 0.15 plus 0.15, I will get from this point to this point, I get the time taken 0.3 seconds. The time taken from this point to this point. Great. This position is x initial, and this position is x final. X initial is 0, I think not clear, 0, 10, 20, 30, 40, 50. X initial is 10 meter or centimeter. X final is 50 centimeter. So that the displacement is delta x is x final minus x initial. 50 minus 10 will be 40 centimeter. The answer is D. The next question, depending on the figure, what is the displacement for the runner after 6 seconds? The time period is 2 seconds. We can calculate it. It's easy. From here to here 2 seconds, and another 2 seconds, third 2 seconds. The total time from this point to this point, the total time taken during this time is 6 seconds. X initial is 10 meter. X final is 25 meter. The displacement is what? X final minus X initial will be 25 minus 10 will be 15 meter in positive direction, as you see in the figure. The next question, depending on the position time graph for an object, what is the average velocity for this? It's easy. I can take 2 points. I can take 2 points and calculate the slope. The slope equal average velocity. This point is 3, 9. This point is 0, 3. Average velocity equal slope equal y2 minus y1 divide x2 minus x1. The slope will equal 9 minus 3 divide 3 minus 0, 6 minus 3. It will be 2 meter per second. This is answer for the question. Again, calculate the average velocity. You can do it by yourself. What about this equation? Depending on the position time graph for the motion of a car moving west, what the position of the car after 50 seconds if it continues its motion with the same average velocity? Look to this line. There is equation for the straight line y equal mx plus b. M is the slope, b is the intercept point, the first point in y-axis, y is y-axis, x is x-axis. This equation we can translate it in physics. We can write it in physics as, Ly is the position, x equal slope is velocity, v, multiply by x, t, plus initial position. This is the same equation but in physics. So that how can we calculate the slope? V equal slope equal y2 minus y1 divide what? y2 minus y1 divide x2 minus x1. We can take 2 points. This point 0, 60. This point 20, 0. The final is 0 minus 60 divide x2 is 20 minus 0, negative 60 divides negative 20, it will be negative 3. Is it correct? Inshallah correct. Negative 3 meter per second. We can take this and write it in the equation. He asked about what? Depending on the graph for the motion of the car. What is the position? He asked about the position. He need x equal velocity negative 3 multiply by at 50 second time is 50 plus intercept point or the initial point is 60. Is it correct? Yes. I'm sorry. X equal negative 150 plus 60, it will be negative 90 meter. This is the position at what? The position at 50 seconds. Thank you so much. Wait me in the next video. Assalamu alaikum.